Hello class, today we are going to discuss about real number and exponents. So first of all, let's start with real number. That is, what are real numbers? So a real number are those numbers that can be located on a number line. So any number that we can locate on a number line is called a real number. Now there are two subsets of real number, which is known as rational and irrational number. So I hope you have heard about it, but still I am going to explain that. That is rational number and irrational number. So if we talk about a rational number, so a rational number is a number that can be expressed as a fraction. So a fractions are the examples of rational number. The second thing is that a repetitive and terminating decimals are also known as rational numbers, are called rational numbers. So if we talk about examples of rational number, we can say 2, -5/7, -9/11, 3.333. These are all the examples of rational number. Now let's talk about irrational numbers. So irrational numbers are those numbers that can't be expressed as a fraction. So a number that can't be expressed as a fraction. Also, an irrational number are those numbers which are non-repetitive as well as non-terminating. Okay, so a non-repetitive and non-terminating decimals are also called irrational number. So if we talk about the examples of this one, you can write it as √5 pi, because the 3.14 is the estimated value of pi. It is not the actual value. Similarly, you can write √7/2. These are all the examples of irrational number, or you can write it as 2.15432619, and this will go on. It means that it will not terminate. So these are all the examples of irrational number. Now if we talk about subset of rational numbers, so there are 3 to 4 subsets of rational number. The first one is whole number, and you know that all natural numbers are whole number, so natural number will also come in this category. Then you can write integers, you can write it as fractions. So these are all the examples of rational number. Now let's talk about exponent rules. So there are mainly 8 exponent rules. The first one is a to the power m times a to the power n. It means that if bases are same but power are different, then we are going to add the power. That is a to the power m plus n. The second one is a to the power m over a to the power n. It means that you can write it as a to the power m minus n. The third one is if a to the power 0 is given, you can write it as equal to 1. The fourth one is If a to the power negative n is given, you can write it as 1 over a to the power n. Fifth one is if a to the power m times b to the power m. In this one, you can see that powers are same, that is exponents are same, but bases are different. So it is going to be a times b to the power m. The sixth one is if a to the power m whole power n is given, you can write it as a to the power m times n. The seventh one is if nth root of a is given, you can write it as a to the power 1 over n. And the last one, that is eighth one, is if nth root of a to the power m is given, you can write it as a to the power m over n. I hope you have no doubt in this one. Now let's take one question from this one. Suppose you have if 3x minus 2y is equal to 5, then find the value of 8 to the power x and 4 to the power y. So let's solve this one. Suppose we have 8 to the power x over 4 to the power y, right? Can we write this 8 as 2 to the power 3 whole power x? Similarly, can we write this 4 as 2 to the power 2 whole power y? So from here you will get it as 2 to the power 3x over 2 to the power 2y. We have used this formula, the sixth one, in this one. Okay, now we are going to use the quotient formula for the exponent. So we can write this one as 2 to the power 3x minus 2y. Now if we see the question, we have given that 3x minus 2y is equal to 5, right? So you can write 3x minus 2y as 2 to the power 5, which will be basically equal to 32. So I hope you have no doubt in this one. Now let's talk about other things, that is radicals and its properties. So if we talk about radicals and its properties, the most important thing you need to know that if this nth root of a is given, then the n here is called radical and the a here is known as radicand. So let's start with the properties of radicals. So the first one is for addition and subtraction. So if we talk about the properties of addition and subtraction, then two radical numbers can be added only when both the radical and the radicand are same. So for example, if we have to add root 2 plus 5 root 2, you can write it as 6 root 2. Similarly, if you have given cube root of 7 plus cube 6 times of cube root of 7, then you can write it as 7 times of cube root of 7. But if you have given root 2 plus cube root 2, then you can't operate it. You can't operate it in this form. Can't operate in this form. So I hope you have no doubt in addition and subtraction of radicals. Now let's talk about the second one, that is multiplication. So in multiplication of radicals, there are three cases. Let's talk about the case 1. So if the radical of two numbers are same but radicand, the radicand is different, then keep the radical same, multiply the radicand. For example, if you have root 2 times root 7, so you can multiply it as root 40. That is, we have kept the radical same, but we have multiplied the radical. Now, the second case is if the radicand are same, but radicals are different. Then we will use exponent rule. For example, you have root 2 plus cube root 2. So, not plus, it is basically multiple. Root 2 times cube root 2. So, now can we write this root 2 as 2 to the power 1 over 2 and this cube root as 2 to the power 1 over 3? Because if nth root of a is given, you can write it as a to the power 1 over n, right? So from here, the bases are same, so we can add the power. So when you will add 1/2 and 1/3, you will get 2 to the power 5 over 6. Or you can write it as 2 to the power, you can leave it like this, or you can write it as 6th root of 2 to the power 5 or 6th root of 32. I hope you have no doubt till here. Now let's talk about the last properties of multiplication of radicals. So it says that if both the radical and the radicand are different, then you can't operate them. In this form. Is it clear? So let's take one example for this one as well. For example, if you need to multiply square root of 2 with cube root of 3, then you can't operate it. So I hope you have no doubt in real numbers, exponent rules and the properties of radicals. Okay, so that's all for today. Thank you.